Hello, welcome. Today I'm going to discuss about the domain and range of a function. Function was discussed in the class, in previous class. Just see, suppose there are two sets, A and B. The name is A and B. A has elements, suppose A, B, C, and it has elements 1, 2, 3, 4, 5, etc. A is related to 1, B is related to, C is related to 3. Then, as you know, it's function from A to B. All the elements of A, that is A, B, C, known as domain of the function. The elements in B related to A, that is 1, 2, 3, known as range of the function, right? And all the elements present in 1, 2, 3, 4, 5, known as codomain of the function, right? And as you know, all the elements present in A and B, that means domain, range, or codomain must be real number. Is it right? Now, if fx is given, any function given, suppose if fx is given, right, then all the possible values, all the possible values of x known as domain of the elements. Right? And all the possible values of fx also known as y is known as range of the function. Range of the function. We will see here the different points to find the domain and range. If you will remember these points, you will set up in your mind these points. Naturally, you will say all the problems of domain and range will be solved. Okay? At first, remember the first point is all the polynomials. Do you know the polynomial? Right? It's from class 8. All the polynomials have domain belongs to all the real numbers. Polynomial means it is the algebraic expression in which power of the variable must be positive integer. Just see. Suppose x square plus 3x minus 1. It is a polynomial because power of x is 2, power of x is 1, positive integer. 2x to the power minus 3 plus 1 is not a polynomial because the power of x is negative. Root 2x cube plus 3x plus 1 is a polynomial because power of x is 3, x is 1. 2 is not the variable term. It is the arbitrary constant or constant. So it may have the power in fraction or in positive integer, negative integer, all the real numbers it may be. Right? So remember always that if you will see in any question that it is a polynomial, right there, domain will be the real numbers. Next points. If fx is linear expression, fx is linear expression. Linear means having degree 1. It has domain belongs to real number and range also belongs to real number. As example, suppose fx is given 2x minus 3. Function gx is given x plus 4, right, etc. If linear, that means of degree 1, linear expression, then always write there domain also real number, range also real number. Naturally, linear function is also polynomial, and in polynomial, domain will be always real number, and range will also be real number. Do you know why? Suppose fx is equal to y, then y will be equal to 2x minus 3. So what will be x? X will be y plus 3 upon 2. Y plus 3 upon 2, it's also linear. So naturally, y will have all the real number, and the value of y is known as range. It's clear? See the next point. If any polynomial, next point, if any polynomial is in the form of ax upon bx, naturally, bx should not be equal to 0. So in domain, the values of x will not be included. That will be evaluated from here. As the example, suppose we are writing fx is equal to x minus 3 upon 2x plus 4. Right? So 2x plus 4 should not be 0. That means x should not be equal to minus 2. In numerator, it is a linear expression. So its domain will be all the real numbers. So all the real numbers except minus 2. So you will write here domain belongs to all the real number minus 2. Is it right? To find the range, suppose fx is equal to y. Y is equal to x minus 3 upon 2x plus 4. Now make x subject as taking cross multiplication 2xy plus 4y will be equal to x minus 3, or x will be equal to 4y plus 3 upon 1 minus 2y. Now again, 1 minus 2y should not be equal to 0. And in numerator, it is a linear expression. So y will have all the real numbers, but except y is equal to half. Because if you will take y half, then denominator will be 0. So range will be all the real numbers minus 1 upon 2. Clear? Again, see the next point to find the domain and range. If fx is in the form of quadratic, that means of degree 2, ax square plus bx plus c. As you know, a should not be equal to 0, because if a will be 0, then it will not be a quadratic, it will be linear expression. Quadratic is also a polynomial, so one point is clear, domain belongs to all the real number. But to find the range, from quadratic equation, if a is positive, then its range becomes minus d upon 4a to infinity. And if a is negative, then range becomes minus infinity to minus d upon 4a, where d is discriminant b square minus 4ac from quadratic equation. Right? You are well familiar to this one from quadratic equation. Or you can use another method also. Suppose fx is equal to y, so y will be equal to ax square plus bx plus c. Making quadratic in x, we can write here ax square plus bx plus c minus y is equal to 0. Naturally, its discriminant will be greater than equal to 0, because x means domain, and domain always must be real numbers. And for roots real number, discriminant must be greater than equal to 0. That means b square minus 4 into a into c minus y must be greater than equal to 0. You will find y, that will be the range of the function. So these are the two methods, although this will be easy. Direct put the value of d and a. Right? See one example. Suppose fx is given x square minus 5x plus 6. It is quadratic equation. So domain of the function will be all the real number. All the real number we can also write in this way: open interval minus infinity and infinity. Clear? To find the range, first method is find the discriminant, that is b square minus 4ac. b is here minus 5 whole square will be 25 minus 4a 1 c 6, that is 1. Clear? Minus d upon 4a will be equal to minus 1 upon 4 into 1, that is minus 1 by 4. So range will be, a is here positive. In case of positive, the range is minus d upon 4a to infinity. It's clear? Another method. Suppose fx is equal to y, so y will be equal to x square minus 5x plus 6, or x square minus 5x plus 6 minus y will be equal to 0. Now for real x, as just I have discussed, discriminant must be greater than equal to 0. B square minus 4ac must be greater than equal to 0. Right? In place of B, you have minus 5. So 25 minus 4 into A is 1. And in place of C, you have 6 minus Y. Greater than equal to 0, it will be greater than equal to, or 25 minus 24, 1 plus 4y greater than equal to 0, or y is greater than equal to minus 1 by 4. The same answer. So range will be minus 1 by 4 to infinity. That's right. See the next point. Any problem? Next point. If function is given in under root, fx is given in under root any function, right? Naturally, ax must be greater than equal to 0, and you will find the possible values of x, that will be the domain. To find range, y is equal to under root ax, or ax is equal to y square. Again, make x as subject, as just I have discussed. So from here also find y, but from the values of y, you will take only positive value. So range here can't be negative. As suppose y comes minus 6 to 8, its range will be 0 to 8. Right? Suppose y comes minus 2 to 0, union 3 to 7. Right? Its range will be 0 including, right, open 3. No. Its range will be 3 to 7 union 0, because 0 is in closed interval. Right? See one example. Suppose fx is given under root x square minus 5x minus 6. Right? Ax should be greater than equal to 0. Ax means x square minus 5x minus 6. So x square minus 5x minus 6 should be greater than equal to 0. Factorize it. X minus 6, x plus 1 should be greater than equal to 0. Critical points are minus 1 and 6, plus, minus, plus. So x will be equal to, x will be, that means domain will be minus infinity to minus 1 union 6 to infinity. Right? To find range, suppose fx is equal to y. Right? So y is equal to x square minus 5x minus 6. Squaring both sides. x square minus 5x minus 6 minus y square should be equal to 0. Again, x in quadratic, that will be real number because domain must be real number. So its discriminant must be greater than equal to 0. B square minus 4ac, that means 25 minus 4 into 1 into minus 6 minus y square greater than equal to 0. 49 plus 4y square greater than equal to 0. Now see here, for any real value of y, positive, negative, fraction, integer, it will always be positive, no? Because a square plus b square for any value of a and b always greater than 0. If you will take 0, then also 0. So y is equal to all the real number. But as discussed, range can't be negative. Always remember, this point must be remembered. Range in root can't be negative. So here range will be only positive value. Range of the function belongs to not all r plus, or you can write 0 to infinity. Clear? Let us see the next point. Suppose fx is given in the form of a to the power x. That means in the form of exponent. As you know from the graph of exponent, a should be greater than 0, a is not equal to 1, and x belongs to all the real number. Ax always greater than 0. It's clear? In function chapter, in graph, the exponent and logarithm, it's clear that graph comes above the x-axis. No, it was discussed in the class, right? This is when a greater than 1. This is when a is less than 1 but greater than 0. So always graph comes above the x-axis. That's why we are saying that ax always greater than 0. It's clear? Just see one example. Suppose 2 to the power x plus 2 to the power fx is equal to 2, and you have to find the domain and range. That means 2x plus 2 to the power y is equal to 2. Suppose fx is equal to y. I had explained 2 to the power y will be equal to 2 minus 2 to the power x. And this will always be greater than 0. Exponent always greater than 0. That means its value 2 minus 2x will also be greater than 0. 2 is greater than 2x. Power take 1. 1 is greater than x because same base. So x is less than 1. That means domain belongs to minus infinity and 1, between minus infinity and 1. To find range, 2 to the power x will be equal to 2 minus 2 to the power y. Again, this will be greater than 0. So 2 minus 2 to the power y greater than 0. In the same way, you will see y is less than 1. So range belongs to minus infinity and 1. Right? In exponent for inequality, must remember, if a to the power x or y greater than a to the power, suppose k is any real number, then x will also be greater than k, but condition must be there, a greater than 1. But if a is less than 1 and a is greater than 0, if a is less than 1 but greater than 0, then always remember the inequality, sign of inequality will be interchanged as 1 by 3 to the power x is greater than 1 by 3 to the power y to the power suppose 5, then x is less than 5 because base a lies between 0 and 1. It's clear? So always remember these points, very important points it is. Clear? Let us see the next point. Suppose fx is a logarithmic function, log x to the base a. As you know from the graph of log, x must be greater than 0, a must be greater than 0, a should not be equal to 1. And as in graph of log, suppose a greater than 1, log, the graph of log comes in this way. So the range will be minus infinity to infinity. Range belongs to minus infinity to infinity. But sometimes you will say that it will not be equal to all the real numbers. Okay, I will explain with the example. Similarly, if a is less than 1 greater than 0, graph of log comes in this way, again minus infinity to infinity. See one example. Suppose fx is given log 10 base x plus 3 upon x square plus 5x plus 6. And you have to find the domain, right? To find the domain, x square plus 5x plus 6 should not be 0. In one of the points, it was explained, denominator should not be 0. X minus 2, x square plus x plus 2, x plus 3 should not be equal to 0. So x will not be equal to minus 2 minus 3, right? For numerator, for log, x plus 3 must be greater than 0. Log x, in place of x, you have x plus 3. So x is greater than minus 3. Now put all the numbers on number line. Minus 3, minus 2, minus 1, 0, etc. From this one, x must be greater than minus 3. But in between, minus 2 will not be present because here minus 2 is excluded. So the range will be minus 3 to minus 2, open interval, that means excluded both the elements, union minus 2 to infinity. Right? Again, see the next point. Suppose fx is given in the form of NPR or NCR. That means permutation and combination. Naturally, n counting numbers should be greater than 0. From permutation and combination, r must be greater than equal to 0. N must be greater than equal to 0. Here, n and r must belongs to positive integer because it is counting number. In this case, always remember domain or range must be written in the form of elements of the set as 2, 3, 5, etc. You can't write here domain range in interval, as suppose x comes less than 6, greater than 1. Then you will write domain belongs to, suppose it is equal to also one side, domain belongs to 1 greater than 1. The elements should be 2, 3, 4, 5, 6. In this way, you will write here domain and range. Right? Sometimes one of the options in examination is given in this way. So this will not be the right answer. I see one example. Suppose fx is given 7 minus x, p permutation x minus 3, or cx minus 3. Both will have the same way to find domain and range. Now, n greater than 0, that means in place of n, you have 7 minus x greater than 0. So x will be less than 7, 1 point. R should be greater than equal to 0. In place of R, you have x minus 3. So x minus 3 should be greater than equal to 0. That is, x is greater than equal to 3. Second point. Third point is n greater than equal to r. So 7 minus x should be greater than equal to x minus 3. Or 10 is greater than equal to 2x. So x less than equal to 5. Now put on the number line. 3, 5, 7. Right? X less than 7. So this will be the result. X greater than equal to 3. This will be the result. X less than equal to 5. This will be the result. So common portion is from 3 to 5. So x belongs to 3 to 5. But you have take the elements, integral elements, positive integer. So domain will be 3 included, 5 included. So 3, 4, 5. Right? Its range, to find the range. Suppose in examination, you have to find only range. In spite of this one, you will have to find the domain at first in this type of question. So range will be f of 3, f of 4, f of 5. You can find the f3 as 7 minus 3, p 3 minus 3. That is 4p0. You can calculate there one. And as you know, the formula for NPR is factorial n upon n minus r. No. And NCR is factorial n upon factorial r factorial n minus r. Right? So this is the way to find the domain and range of function in the form of NPR or NCR. Let us see the next point. If fx is given in the form of a cos x plus b sin x plus c, right? It is given in the form of a cos x plus b sin x plus c. Here a, b, c are real numbers. A, b, c are real numbers, may be positive or negative. That means constant value. Naturally, if it is sine and cos both are defined for all the real numbers. So x will have the real numbers. That means domain will be all the real numbers. But to find the range, you will use from trigonometry, its range is minus of a square plus b square plus c. If c is not given, then leave that, to under root a square plus b square plus c. This is the way to find the domain and range for the function a cos plus b sin plus c, right? Suppose fx is given 3 sin x minus 4 cos x plus 6. From this expression, if you will compare, a is minus 4, b is 3, c is 6. So at first find a square plus b square, that will be 16 plus 9 under root, that will be 5. Is it clear? So range will be, put here the value of a and a square plus b square under root and c. So minus 5 plus 6 to 5 plus 6. That means 1 to 11. Right? Is it clear? And last point will be, if fx is in the form of increasing or decreasing, if fx is increasing, no, this will be the second last point, increasing in a to b. Increasing means f dash x will be greater than 0. Right? You may see with the graph. Suppose xy axis and graph comes in this way. On x-axis A, on x-axis B. And y is equal to fx is the graph. What will be at this point value? Fa, here fb. So range will be fa to fb. Although you will see the questions related to this one in application of derivative, right? If fx is decreasing, in A to B, if here there will be open interval, then answer will also be in open interval, and similarly here also. Suppose graph comes in this way, here B and here A. A to B graph is decreasing. So FA will have the greater value than comparison to FB. So this time range of the function belongs to FB to FA. And you will see the problems in the application of derivative. And last point, if fx is equal to the sum of different functions, suppose f1x plus f2x plus f3x fnx. Suppose n term, there may be 2 term, 3 term, 4 term, etc. Each function is positive. Each function is positive. Product of all the functions, product of all the functions means f1x, f2x, f3x, is constant. Then to find the range, domain is given all the positive values. Then to find the range, use arithmetic mean is greater than equal to geometric mean. You are familiar to arithmetic mean and geometric mean? Arithmetic mean of A and B is A plus B upon 2. It's from sequence and series. Geometric mean of A and B will be AB to the power half. Suppose there are 3 terms, arithmetic mean of A, B, C will be A plus B plus C upon 3. And geometric mean of ABC will be ABC to the power 1.3. So you will, this formula arithmetic mean is always greater than equal to geometric mean. Right? See one example. Suppose fx is given x plus 1 by x plus sine x plus cosec x. Right? X given between 0 and pi. Between 0 and pi, all the term will be positive, 0 to 3.14. Sine will also be positive. Cosec will also be positive. So each function is positive here. Now see what is the product of this term. Product of this, and this is 1. Sine into cosec 1, x into 1 by x. Product is 1. So apply am greater than equal to gm. There are 4 terms. So fx by 4 is greater than equal to 1 to the power 1 by 4. Product to the power 1 by 4 because there are 4 terms. So fx is greater than equal to 4. So range becomes 4 to infinity. Right?